Hello and welcome to the Net Zero Compare podcast. Today, I'm speaking with Josh Harrison, Director of the Center for the Study of the Force Majeure at the University of California, Santa Cruz. The center brings together people from different fields, including science, engineering, planning, public policy, art, and land management, to work on practical responses to climate change and environmental disruption. Josh is also involved in projects including Living Forests, which looks at wildfire resilience, forest restoration, water, local economies, and the use of wood removed for responsible forest management. He also works with Leaf Island, which focuses on helping cities function more like natural ecosystems through better use of plants, water, soil, and recycled materials. This is an important topic for businesses and decision makers because climate adaptation is becoming a practical operational issue. Wildfire, water shortages, urban heat, insurance, construction materials, and infrastructure risk can all affect where companies invest and how they operate. Josh, thank you for joining me today.
Thank you, Carol. It's a pleasure to be here.
My pleasure. And maybe to start, could you tell us a little bit about your background and what led you to work across areas such as forest restoration, urban infrastructure, public policy, and climate adoption?
Well, I have kind of mixed background. My parents were environmental artists, which meant that I grew up in a childhood where there were very few disciplinary boundaries. Sometimes there'd be a physicist at dinner, sometimes there'd be an artist at dinner, sometimes there'd be musicians. So I grew up in an environment where it was common to talk about big problems. It was common to think about ways to do it. And interestingly enough, from their perspective, my family business became solving very complicated, interesting questions that had not yet really been resolved. And those ranged from being the first people in the world to understand how to grow and raise crabs in captivity and allow them to reproduce successfully, which meant that two artists actually created a whole aquaculture industry through decapod research, and they were the first people to ever get a Sea Grant from the Scripps Institute of Oceanography as artists. Later, that emerged into projects about restoring and creating a master plan for the environmental sustainability of the Sava River and later the Drava River, both the main and third main tributary to the Danube. That also turned into planning structures for the province of Holland that reworked about $230 billion worth of housing construction from outfill to infill and preserved the central green lands, commonly called the green heart of that country, in the face of 2 or 3 years of deadlock with the normal planning structures. So I come out of a background where different problems were treated as things you could look at, and if you didn't, and you, from a perspective of, I guess, a inspired generalist and who stood nearby, who knew enough to bring expertise in, but didn't feel constrained by the institutional structures of the kind of formal training that most people who go through an engineering education get, or who are deep in a particular discipline. And I think that's been kind of the story of my life and the different processes I've done. As a student during the first energy crisis in Southern California, the second energy crisis, in the late 1970s, I was at a very technically oriented institution, and it was hot out. It was in Southern California, and I asked myself, I'd like to learn about solar energy. There was for some reason, despite the fact that there were a lot of physicists and a lot of chemists and a lot of engineers on campus, nobody thought it was relevant then in 1978 to study solar energy. So I founded a group called Students for Solar Energy, and we brought the first major energy market, first alternative energy market in Southern California to the campus, which made them very happy because suddenly we're doing things. And then I got them to change their building plan so that new construction would take solar and energy conservation into consideration differently. So I learned from, and of course, I have a lifetime of different stories like that. But so I understood that sometimes you just have to ask the question. Sometimes you just have to look at something somewhat differently and say, why not? Why don't we do this? Not just, as opposed to the other side, which is, oh, you can't do that. Here are all the reasons that you can't do this. And I look at, well, here are the reasons you can, and let's start thinking about that. And, as a nation, I think one of the things that has transformed our country in the last 40 or 50 years is that we've moved from a nation, the United States I'm speaking of in particular, from a nation that took on big projects and understood big ideas to a nation that is terrified of risk and is risk averse beyond any rational understanding. And so the slightest issue that might come up is more than enough issue to say no. So, instead of building, tens of thousands of miles of roadways that we did from the 60s to the 80s, it costs us as much to build a 3 or 4 mile stretch of 8-lane highway today as it costs us to build 1,000 miles, 25 years ago. Okay, it's not just inflation. We just no longer think about how to do that. So part of what I look at is how you change those conversations and why.
It really sounds like you came to this work by looking at several problems that connect rather than treating each one separately, which is a great view. When you look at the major climate challenge, how do you begin breaking it down? Because people often use the term systems thinking, but it can sound quite abstract. In practical terms, if you could tell us, when you look at the problem such as wildfire, drought, urban heat, or flooding, how do you decide which parts of the system need to change?
Well, that's a really important question. I think the simplest way to think about systems is, something that's not very mysterious. Everything's interconnected. It's as simple as that. That we live in a complex series of interactive, interdependent feedback loops. That's a more complicated way of saying the same thing. The issue is that we've trained ourselves as scientists and engineers to figure out how to find the pure answer. So we ignore friction, we assume all of these variables are external to our problem, and then we concentrate on what we think of as the essence of a problem. I look at it as the friction is the problem. It's not the thing we have to get rid of, it's the thing that makes the problem real. So how do we address the world where the externalities are not external, where the friction is real, where the problems, when you solve them, have to include the impact of those problems? And in forestry, I look at a number of different things, but first, it's a landscape. It's not a forest. Forest is a part of a landscape. It's got an atmosphere. It's got a hydrologic cycle that plays into it. It's got a soil and water cycle that plays into it. It's got a tree growth and forest management cycle that plays into it. All of these things exist and are very interconnected. And if you're looking at fire, for example, I guess what I would say is, we're living right now, this year, I think, has been a year where more and more people are recognizing that these large natural calamities that we've been talking about, that we've been experiencing, aren't just one-off events that are just the luck of the draw, or as my name of my institution say, acts of force majeure, which is a French legal term we use for acts of God that insurance companies use when they tell you that they can't afford to pay you out because you paid for storm insurance, and rain and wind is not a storm, it's an act of God, therefore it's not covered So we look at the knockoff effects of what that means, which is how we developed our name. But if you look at something like fire and storms and flooding, people are starting to realize that those aren't one-off accidents that happen. Those are parts of the climate. Technically what the climate is doing is discharging heat in different ways. It's taking energy and it's taking it from one form to another. There's just, with all the heat that's been added to the atmosphere, there's a lot more energy to be discharged. And some of it takes place in bigger and nastier and uglier storms that get stronger and stronger. Some of it takes place in flooding that we aren't used to, in winds and water and wave action we aren't used to, and some of it takes place in forests that grow differently and that are more susceptible to massive burning, particularly when they haven't been managed very well. Okay, so with fire with a forest in a particular case, there are lots of issues. Right now, we're seeing one of them in a Mediterranean climate, like the one in California, like the one in the Mediterranean, like the one that's from Spain, from Portugal, all the way through Turkey and continuing on the south side as well. You have a condition where you have a wet winter, short wet winter, and a long, dry, hot summer, which are perfect conditions for things to grow rapidly in the winter, to dry out, tinder dry, and become very susceptible to fire over the length of the summer. So these are environments where fire is actually an active part, and the trees and plants have grown to adapt to that. Many of the trees thrive under certain burning conditions. Their pine cones will germinate. They need heat to germinate. Certain kinds of oaks scatter and fires clean out brush, so they help provide more space for the trees that survived. And if you bring fire into active management, as the people who have lived in those areas have for thousands of years. Now, in California, the current forest cover emerged as the last ice age retreated. So as the ice and snow melted and the landscape started to recover its soil base, the trees started to grow in quantity. And at the same time, people who had lived there for some time, started to live there in much greater amounts because the food was better. There's a reason people like to live in Mediterranean climates. They're nice places to live.
As we said, everything is interconnected. Exactly.
Yes. Right. So, it's no surprise that people have always wanted to live in Mediterranean climates, wherever they happen to be. And so the native people everywhere, and I'll just use the California example, but similar things happened everywhere this process existed, was they spent a tremendous amount of time in very close physical proximity to the landscape, which meant that close observation showed them that fires were happening. And it encouraged them to test whether they could use that fire that was already happening intentionally. And if they could use that to nurture certain kinds of plants that they wanted for food, acorns and certain kinds of pines, pinyon pines, whether they could use materials they used for basket weaving and for other things. They can encourage the willows to grow differently. Or they could encourage other kinds of food plants or medicinal plants or sacred plants that were needed for rituals. And they recognized that by intentionally burning small areas, they could actually start to essentially use fire to garden, to tend, to steward, we use different terms, the landscape. And they did that. And they did that for thousands of years until the Europeans came. And the Europeans came with from crowded cities where they used fire for food and they used fire for candlelight and lantern light. And their cities were often made of wood that were crowded together. And if a lantern fell over or fires got out of control that was heating a barn, it was catastrophic. So they were terrified of fire. So when, of course, they came, the first thing the Spanish did charming thing that they did was they rounded up all the natives they could into what you can only call concentration camps so they could provide labor. But even so, they saw that the people were like escaping at night from these concentration camps and going off and setting these small fires in neighborhoods that had formerly been their farmland and their food lands. And the Spanish assumed that they were doing something that was designed to be sabotage, or they were planning some kind of revolt, and they started to punish people for starting fires. And that was how we began essentially in California, longer than in the rest of the West, a 250-year tradition of fire suppression. Okay, now I'll shift to the other side. So by doing that, they broke this pattern of using fire to thin the land, using fire to encourage the larger trees and discourage the smaller trees, and create this open-aired, widely spread, what you might call patchy forest, where there's a forest intermixed with a meadow. By the way, that meadow serves as a fire break, so that when the fire does happen, it runs out of fuel very quickly and then stops and self-extinguishes. This was something that took modern scientists a long time to understand, that those were intentional processes. But if you look at for example, if you're in the East, or you're in a rainy part, or you're in Germany, or I imagine Poland has a similar climate, although I've never don't know it exactly. And you look at a forest, it's heavy, it's green, it's covered with, it looks, that's what a healthy forest looks like. A panorama of lots of trees. And if you take that image that you bring with you from Europe and you reinstall it in New England, and you then think about it, it's different from the ones in Spain. The forests are different, come back, and they come in, and you look at this mountainside and it's all covered with green. You say to yourself, and as people did in California, oh, that's healthy. Well, okay, that cover just mathematically to create a pine-covered leafy green forest that looks green from a distance, you're talking 350 to 400 what they call tree stems. Well, historically, we understand through a lot of research what the native people knew intuitively, but we learned it our own way. A really healthy Western forest currently, before climate stress, this is before climate stress, is 35, maybe 40 trees spread out thinly in irregular patches across that same landscape. That's an order of magnitude different in the amount of woody biomass, fuel, what they call fuel load on that landscape. That's what's burning. That's why those fires are so big. Those areas where their fire has accumulated, they haven't been treated, they have as much as an order of magnitude more burnable material on them than they're designed to carry. And so that's an inherently unstable process. And that's what's happening in France and Portugal and Spain. No differently. In Europe, a lot of that work that native people did for their own was done by charcoal gleaners and other people who basically tended the forest because they were capturing, the woody biomass in the scrub and the brush and the small branches to turn into charcoal. But when the charcoal economy disappears, that work disappears. And when that work disappears and people go into the cities because they can't form a living in the forest anymore, the management stops, and then, all similar things happen in Europe that have happened in the United States. And this is, again, speaking of Mediterranean forests, all forests burn in different ways. So, without getting too deep in the weeds, we're already pretty deep in the weeds. Without getting too deep in the weeds, we'll just stay with Mediterranean style forests. So that only gets you part of the problem. Then you say, how do you respond to that? Well, the first thing you have to say is, if there's too much wood and what they call woody biomass on the landscape, but what you really want to do is have a fire adapted landscape. So your end goal is to have what foresters call good fire. This is the kind of fire that burns irregularly at a much lower temperature and does all the cleansing and productive and bioenrichment that the fires do traditionally, or what the native people call, cultural burning. because it's embedded in the culture of their lives. If you want to bring that back, you have to somehow go from the forest you have to a forest where you can set those fires without creating giant, out-of-control wildfires that are exactly the opposite of what you want. So that means you have to find ways to ecologically and environmentally remove all of that excess biomass, as much as 50, 60, 75% of the cover that's on that land. But you have to do it in a way that's not destructive. So that sounds good in principle. Then what happens? Well, then you discover that, not discover, but then you run into the fact that wood's heavy, really heavy. A cubic meter of wood is a ton, and most of that's carbon. If it's a softwood, it's about 96, 97% carbon. If it's a hardwood, it's more. I mean, that's a lot of carbon, a lot of weight. And these are in mountains. They're not very close to roads, most of them. In fact, there's been a lot of environmental push in forested areas against roads, because roads are not, can be pretty destructive to the landscape in general. So a lot of these places, and let's just make it more complicated, since everything's interconnected. The timber industry in California collapsed in the late 1980s and early 1990s. So there are not even very many places you can process this wood. So it's heavy. You have to and it's expensive to do that. You can't carry a ton on your back and hike it out, and even if you could, it's kind of a very, very slow way to get rid of. There's easily 7 or 8 million hectares of landscape, 13, 14 million acres of primary and another 20 million acres of secondary lands that are at severe, in fact, technically now all of California's have fire risk, because historically it's a fire risk. It's the culture, it's the climate. But there's 10 or 12 million heavily forested acres that need to be treated. And the current plan says they want to treat 1 million of those acres a year over the next 10 to 12 years. Now, they've got to the point where they've treated totally about 700,000 acres. So we're, shall we say, a little bit behind the 8 ball. But that's better than it was 7 or 8 years ago, when it was 10,000 acres a year. Okay, so it costs money to do this, $2,500 to $4,000 an acre. It's gone up dramatically, but so it's, 1 million acres is, call it on the top side, $4 billion a year. That's a big number. Now, the fires that took place in January in Santa Monica, or the Paradise Fire, which is one of the biggest, most dangerous previous fire, both of them cost hundreds of billions of dollars in damages. So the ratio of money saved to money spent is massively in favor of prevention. The moral mechanics are massively in favor of prevention. The institutional financial mechanics haven't figured it out yet. They're way behind, So the state has a certain budget. The Forest Service has a certain budget. None of those budgets are calculated on the value of what they're not spending if they actually do the prevention. They're all calculated on present value of the wood. So there's a big disconnect between how we finance this work. And there's lots of interesting groups working at trying to help figure that out and get better. As I said, we're at 700 or 800,000 acres done, and we're up to 1.5 million next year. It's going in the right direction. It's just not going fast enough in the right direction, but it's going in the right direction. But that all has to, so those are all, we can go on, but those are all some of the issues that come in. Oh, well, no, let me add one more thing. Now, this wood, because now we're going back to climate. What is this wood? This is carbon. All right? Well, what do you want to do with carbon that you take off the land? Well, you can do a bunch of things with it, but the smartest thing to do is to bank that carbon. Once you take it off the land and you don't burn it, then that's carbon that you've extracted from the system. and it's not carbon that you're putting back into the system because you've taken it off of the land and you burnt it. That's a cyclical process that doesn't change your carbon balance by pulling the carbon out. And how do you want to park it? Well, you can park it in essentially three ways. You can build, bury, or you can burn it anyway and pretend that's okay. We're going to ignore that third part because it's the easiest one, and naturally it's the one that everybody wants to do because it's cheap, and Japan wants to buy a whole bunch of California-based wood chips, and England wants to buy a whole bunch of other wood chips from, from the southeast of the United States, and everybody sits around and tells themselves that as long as it's wood that's from trees that have already grown and you're just burning it, you're not really doing anything. And somehow it's better than natural gas, and somehow it's better than coal. Anyway, it's a bad, we can accept that it's happening, but we should be moving away from it. But the other two ways are you can bury it, you can bring it back, put it back into the soil in multiple different configurations. You can turn it into you can leave it alone, which is one of the simpler things to do. It's the cheapest thing to do, but of course it leaves a whole bunch of wood in piles, what they call stranded piles, that's ready to burn. So you haven't really solved your fire problem by doing that. You've done some work towards the other problems. You've thinned your forest. You've helped the soil recover. You've done other good things, but you have basically now in an area like central Sierra Nevada, near Lake Tahoe, there are somewhere between 400 and 700,000, an uncountable number of stranded piles. So everybody who's concerned about fire in the Sierra Nevada is like, what do we do about these things? We can't take, and some of them are 15, 20 years old. So there's not even any real salvage value. It's a fairly dry climate. So they take a long time to decay. So, you're caught between those two, problems. But for the rest of us, you can turn it in. There's lots of interesting technologies, anaerobic burning, which, they call pyrolysis, which allows you to generate some power, some heat, some petrochemicals, and then some pretty cool soil additives out of it. Some of the new technologies for pyrolysis are portable, so they solve you have to take the wood to the factory by taking the factory to the wood. And those are pretty cool. And those also work with farm wastes and farm residues. So there's lots of multiple uses for some of these technologies. So that's one interesting, it's not enough to answer the whole question, but it's an interesting piece of it. And you can, for local communities who are interested in their own local power, which is a pretty important generation, that can be part of the anchoring facility for, power generation for communities. So lots of things for that. But the most important use of this wood is to park it in building materials, whether it's as traditional timber or whether it's as structural wood-based laminate that can adapt to these smaller trees that are the basic tree stem that has to come out. It doesn't have other commercial value, and turn that in buildings. Because at the same time as all this is going on, California and much of the United States is suffering from a severe housing shortage. And they don't use California wood to the extent that they use wood. They do a lot of wood building in California, but they import it from Canada and the northern state of Oregon because they like the particular tree that grows there more than they like the particular tree that grows in the species that grow in California. The builders' strength difference is real but marginal. Any home older than, say, 50 years old that's made in California is using that wood that's considered terrible today for most building construction. So it's not like you can't use it, but they don't. So there's no market for it. There's no factories for it. There's a tremendous need for it. And if you take the wood from California off and put it into California housing, you are reducing the California forest fire and you're solving the California housing crisis with the same act. And if you build new factories to do that, you're solving a workflow crisis at the same time. And then you're in a situation where let's get back to first principles, where the act of harvesting the forest, the act of building a factory, the act of building are all things that improve the overall landscape and well-being of the landscape. So we're what I call the center, where the harvest preserves the system. So I guess that's walking you through a systems-based look at forests in California. And I've left a few things out, but I think that's probably enough to get the general idea.
If I had to summarize your answer and translate like to business, direct business language, I would say that it is not simply about finding one technology, one new technology, or funding one isolated project. You first need to understand how the environmental, economic, political, and social parts fit together, as you've just said. Let's apply that to your work on forests and wildfire. Through living forests, you connect wildfire risk with forest health, water, biodiversity, employment, and local economic development. If you could tell us, why do you think wildfire has so often been treated as a separate emergency rather than as a part of a much wider problem? That would be great.
I think that's a really important and interesting question. I touched on it a little bit. I think we, particularly in the West, have grown to think of things as singular, isolated events so we can think about them more easily. The idea that even though our mythology is pretty comprehensive, I mean, in Greek mythology, fire is the source of knowledge. It's Prometheus, it's who brings knowledge. In the Judeo-Christian tradition, it's Eve who eats the sacred fruit of knowledge and, pays for it. Well, Prometheus pays for it too. He ended up being stranded on a mountain with eagles eating his liver. So it's not like he did very well from the process. But fire was considered this powerful source of both heat and destruction. In India, Kali, the goddess of fire, the goddess of destruction, the goddess of life. All of these, in many, many cultures, it's been a very important thing. But we managed to think of fire as a standalone event that was primarily destructive. And, there's a lot of stories around how that could happen. But I think a lot of it has to do with we built cities out of wood, and when fires happened, it was calamitous, it was catastrophic. And so we focused quite a bit on that and much less on how fires were engaged in their own organic behavior that was different in different contexts. And we didn't even think about our own use of fire, which even as we're worried about fire, out of control, wildfire, we're using fire for food, we're using fire for light, we're, using fire of various kinds in controlled manners for warfare. We're using fire, across the board in all kinds of ways, while focusing on the image of fire as this giant city burning down or a house burning down or something rather completely destructive. I think in the last few years or decades, that's begun to change, and people are starting to understand these connections, particularly, again, indigenous people have understood this from day zero. They didn't need us. And I suspect if we looked historically, the first proto-hominids that came out of the Olduvai Gorge 4 or 5 million years ago into the savanna, one of the first things they figured out how to do was to use fire. For example, the big plains, whether it's the Targa, the Great Plains in the United States with the buffalo, or the Pampas in Argentina, there's a lot of evidence that the native people used fire to create and maintain feeding grounds for the large hoofed animals that lived there so that they could have ample hunting. So that the Great Plains and the Pampas in particular both have some human impacted origin, and that human impacted origin.
That would explain why short-term emergency responses alone are not enough. One
Right.
of the proposed solutions that I've heard of is more active forest management, although I've also heard from others that that can be a little bit controversial. Forest thinning is often presented as a way to reduce the risk of severe wildfire, but at the same time, we know that people are concerned that it can become another form of commercial logging, right? So how do you distinguish responsible forest restoration from practices that may cause further environmental damage?
I think that's a really important question. I just want to remind us all that people are always managed. Everything we do is managing forests. It's whether we manage it well or poorly. It's not whether we manage.
Let's hope they won't be micromanaging the forest.
Right. That falls under poorly. Um, um, but the useful news is that most of the West and Europe Finland and Scandinavia and Germany are all far ahead of the United States and Canada, but most of the Western forests, I don't want to say Russia because I'm not really familiar with techniques there, are already managed pretty well. Most of the publicly managed forests and much of the private. And they're managed pretty well because there's been a lot of research about what a healthy forest looks like. And there's been a lot of response to the really poor practices that took place for almost 150 years, which was, essentially clear cutting, strip mining a forest, treating it as a resource and abandoning it. Although the Forest Service will say they didn't abandon it, they just put it on a 75-year cycle, which of course functionally doesn't look very much different if you're going through. So where the forest management is absolutely uncontrolled, and again, often financed by the northern western countries, they're not doing it, is what's happening in Indonesia. It's what's happening in Brazil. It's what's happening in the Congo. It's what's happening in the forest in the global south, where the financing that in the United States and Canada and Finland and Norway and Germany understands and is willing to put self-regulation in, sees no need when it's of somebody else's land. And they absolutely strip mine coconut, for copal, for sugarcane, for cattle, depends on whatever the commodity that they prefer to be using. And of course, that is the truly destructive fire practices. That's what's really damaging, like we call it the lungs of the planet. The three major forest areas of tropical forest in Indonesia and Brazil and Africa, are all at serious risk because financing indirectly or directly financed by companies headquartered elsewhere, see no need to provide the same environmental control that they would in their own backyard.
I think that distinction is very important, and also it's a very good point to make and to make it clear for our audience that removing trees is not automatically restoration, and the way the work is planned and managed that makes a major difference. There is also the question of what happens to the wood and other material that is removed. For forest restoration to work at scale, I could imagine there needs to be a practical use for smaller trees and lower value wood, right? So which products or markets do you think offer the most realistic opportunity? And also, what is stopping those markets from growing?
Well, I think that's of course, that's a really critical question, but let's start by an observation that we make is that a tree farm is not a forest. There's room for tree farms, but I think over time we're going to find there are many other things that are more efficient to grow than trees for wood, because the carbon replacement of a tree farm really only happens when the trees are mature. The most wood and the most carbon is stored in a mature tree, not in a growing and young tree. And that's 30, 40 years down the road. When you cut that tree down, you're taking advantage of it now. So you're not getting your carbon benefit for 30 or 40 years, which could easily be too late in any case. But, Secondarily, there are other fast-growing plants like hemp and bamboo and certain kinds of grasses, other kinds of grasses that can provide much of what we're looking for in the terms of certain kinds of fiber than trees do in quantity, and we should be thinking about those. And we are. All of those things are being used. In terms of trees themselves, you're right, the larger trees that get harvested, again, you now know that if a forest needs to be brought back into ecological balance, that often requires not just taking the small trees off, but taking some of the larger trees off, because you don't get from 350 to 400 stems on an acre to 35 stems on an acre only by taking the small trees. And if you don't get that small, it's going to burn anyway. And once you allow the forest to breathe, soil, it's been, we know that soil gets richer, it holds more water, it holds erosion better, the trees themselves are healthier, they resist disease. All these benefits, all the various co-benefits of oxygen and transfer and all those things actually improve paradoxically with fewer mature trees than with more trees. And then you also get mixed heterogeneous landscape, which means you've got the meadowland, which is where your biodiversity explodes as opposed to inside underneath the forest canopy. You get uneven aged trees, which means you build the resilience of the forest as a unit as opposed to the strength of any individual tree. So that's on the forest side. You want to do that. You want to get to the point, and then you maintain it largely with selective timber. So you have this, from a business point of view, another complexity is you have what you might call the big cut and the maintenance cut. The big cut is going from 300 to 400 stems an acre to 30 to 35 stems an acre. The small cut is maintaining that 30 to 35 stems per acre over time after you've done that, and letting it grow to 50, 60, 75 stems, but that's a lot smaller amount of wood that you're harvesting. So you have a business model that has to go through and understand that it's got a resource that can extract a fair bit of raw material from and ecologically and stay in ecological balance. But the second pass is going to be, and the third pass and the fourth pass, even if those are timed at 25-year cycles, are going to be relatively much smaller. So it's a business strategy that has to understand growth and decline while being stable. Not something we like to do very much in our economy. We don't like to plan for short-term growth that turns into long-term, much smaller, consistent growth, or consistent use. So that's strategically a complicated thing to do. That said, what are the materials? What is the market? Well, it's exploding. I have to say, it's not just, it's growing very well. And it's growing in a combination of traditional timbering, which is kind of where it's been, but even more so in these various kinds of manufactured wood products, which are often, it comes in two various flavors. The first one are various kinds of what you might call super plywood, where you take either structural timber and you cross-layer it, and that's what they call traditional mass timber, or you take thin sheets of veneer exactly like you would with plywood, only you make them, again, you layer them in such a way that they become much stronger than traditional plywood, and you use your bindings. They now have, fortunately, durable non-formaldehyde glues that they can use some of them are actually made out of wood resin, so you actually can go. They also now are starting to use what they call dowel laminated timber, which was invented actually in 1970 in Germany, but is now starting to become more commercially available as opposed to...
The owner of the company from Germany that actually uses that kind of timber for data centers construction. He was also a guest on our podcast.
Perfect. See, so you see there's a convergence. Yeah, you can see
Exactly.
there's a convergence. So that's a wonderful product because it takes a little bit more labor, but it's more of 100% usage. It removes a lot of extraneous material. So it's a really great. It's a great. And then there's basically beams, oriented strand board, which is another way of using these timber fibers, and that is very popular now. And all of these materials, as your previous guest might have told you, they're structurally stronger than concrete, and they also, because they're compressed, there's no airspace in them. They actually have a higher burn resistance than concrete, because there's no oxygen access. So they scorch and maintain their strength integrity extremely well under fire conditions. So we're now starting to see them as a concrete substitute, which is why they were originally designed, to be a substitute for concrete. Now it's become environmentally appropriate to use them. And we have this other element from using wood in commercial spaces and eventually in private homes, is that the environment itself, a wood-based environment, has been shown to improve working conditions in job sites. And the initial studies are pretty impressive. They're pretty revealing. They haven't quite been able to tie it to specific kinds of productivity gains, but they're finding major improvements in health and well-being. That's not surprising. And of course, let's get back to fire. One of the biggest risks of being in a fire in a contemporary building is the toxins that are released by all of the artificially manufactured hydrocarbon-based material that's in it. Whether it's in the paints, whether it's in the glues and the surfaces, whether it's what's in your carpeting, all those things release really vile amounts of outgassing and carbon. So the more we replace those and go back to a more natural set of fibers, the less of that we have. So it improves both our passive indoor environments enormously, and under stress, it reduces the amount of outgassing and toxic release of interior materials as well. So the market for mass timber is solid. It's growing. As you can see, it's in data centers. It's in lots and lots of signature buildings. And the goal for mass timber, like the goal for any true green substance, is to move away from the signature, the bespoke solution, and move it into the mass production ordinary commodity. And that's where the next business leap is how do you make the products well enough, effectively enough, and inexpensively enough that you can create what I like to call the IKEA flat pack of green infrastructure.
I'm glad that you mentioned mass timber, because it was one of the possible markets I noted down. Since my background is real estate, I noted down the construction as one of those possible markets, particularly mass timber. And as you mentioned, mass timber is often promoted as a low carbon alternative to steel, concrete. However, there are also questions about where the wood comes from. I also checked online on Reddit. People were arguing how forests are managed. What about transport emissions, fire safety, and how long actually the carbon stays stored? So, in your view, when does mass timber provide a genuine climate benefit, and when can the case for it be overstated?
Well, anything and everything in a commercial world is always overstated. That's the nature of. Do you think people are understating the impact of concrete? Concrete is the most heavily used material on the planet after water. Water first, concrete second. It's on its own, because you have to use heat for concrete. It's 4 to 7% of carbon emissions. But concrete doesn't live without steel. So the steel adds another 4 to 7%. So it's 12, 13%. So that's your baseline when you're talking about emissions from mass timber. And is concrete light? No, it has to be transported. So all of the other infrastructural processes that people object to with everything, you have to understand, you have to level set. They're institutional costs of anything you're taking from one place to another. That's heavy. And so some of those arguments are smart arguments, but they're smart arguments without context. That said, the real problem with mass timber, and it's a real one, and is exactly where you started. It is, how do you take timber from a forest that's well managed and within the boundaries of what you can extract from it in an environmentally sensible and sustainable way, and what's just strip mining a forest? That's a legitimate question. And that's where again, social understanding, where there's a lot of work being done in figuring out how you source your timber, how you make sure it's sourced from responsibly managed forests, how you tag, there's increasing amounts of interest, energy, and importance. That's also true for building construction. That's now one of the conditions of LEED certification, is that you know where your materials come from and how, and you track them, and you have traceability in all these things. And so there's lots of mechanisms that add friction and overhead to the system, but are designed to try and control what you're talking about, which is legitimate, absolutely legitimate, and it's the biggest one. In terms of the durability, they don't, mass timber is a 50-year-old product, so they don't have full life cycle. But let's just say Tokyo has 1,200-year-old wood buildings that are in constant public use. Wood has a minimum lifespan, with maintenance of several hundred years, that you can probably safely say, and much more. You know that why? Because you can look at the half wood housing all over Central Europe, 500, 600, 700, 800 years old. So now let's go to concrete. Now the Romans, give them a lot of credit, they knew how to make concrete that lasts for millennia. They have 2,000-year-old concrete buildings. We, however, in modern technology, do not choose to do Roman-based concrete. We have 75-year, 80-year, maybe 100-year building, and it's planned obsolescence. So that's your benchmark you're looking at. Is it going to last longer than concrete? Most likely, much longer than concrete. Most likely, maybe even an order of magnitude longer than concrete. But certainly twice the half-life, 3 times the half-life of concrete. And with maintenance, it could be indefinitely. You just don't know. But concrete will fail. Steel will fail eventually, unless it's constantly repaired. The real question is, what are these half-lives? What is the failure rate? What's the replacement rate? How much is that factor? And then, what is the inherent carbon in all these different materials? The inherent carbon in mass timber is pretty low. The inherent, because most of that manufacture is actually solar energy coming in and being transferred by these neutral technologies that have nothing to do with extracting carbon. Actually, they are extracting carbon. They're extracting carbon from the air and giving us oxygen, which is an inverted technology from almost any other mechanical manufacturing process we have for a building material. Obviously, if we're looking at housing and we want to have the best inherent carbon we want to look at hay-based housing. We want to look at rammed earth housing. We want to look at adobe. We want to look at material that's, we want to look at local stone, locally harvested wood, timber, whole tree out of local. Those are all manufacturing, which we should not ignore, which have, an even lower inherent carbon footprint than mass timber would, because it's, after all, mass timber's an industrial process like everything else.
I was just thinking that those examples that you gave, again, they make it clear that wood is not automatically sustainable simply because it's renewable. The full supply chain and the lifetime of the building matter. That's what you said. There must be this traceability. And for companies buying these materials, that creates, as I can imagine, a due diligence challenge, another due diligence challenge. Let's say when a developer, construction company, or procurement team is considering regional wood or mass timber, what should they ask suppliers to prove? Let's say, what information should they request about forest management, maybe carbon impact, traceability that we've already talked about, and local community benefits?
Okay, so that's a question that's emerging in its response. But I would say if you're working, mass timber and local wood are designed for different buildings. So the builder who's using local lumber, and again, lumber is not local except areas where there's a lot of it. And in California, for example, where there's a lot of it, it's still not local, as I mentioned earlier, because it's the wrong species. They don't want to use it. And the reason is, that timber doesn't build, there's limits to the scale that individual traditional timber balloon and stick housing, as you call it, can scale to. So it's useful for individual homes and small structures, but probably wouldn't be the same thing. Mass timber is much more small commercial buildings, medium size and larger residential buildings, multi-unit, multi-story, 3, 4, 5-story residential units that could have, or large. And what you would ask, well, there are several certification programs that already exist that do all those things. And you ask that your wood follow those certifications. The challenge for those is that being certified under a certification program is an expensive process. And lots of people who follow good techniques find the cost, particularly if you're a small landholder, and you want to get certified by one of the two main wood certification programs, it's an onerous expense, so people forego it in different ways. A more useful way that's coming up is the sawmill, and put the emphasis on the traceability to the sawmill. And increasingly, there are increasingly responsive and responsible sawmills that are selectively harvesting different kinds of wood in different manners and giving you the traceability. And then they're creating the output. So if you get, for example, your mass plywood, which is one of the several kinds of mass timber from a company like the major mass plywood company in Southern Oregon called the Frères Brothers, they will tell you, where their wood is coming from and what. If you go to one of now a dozen or so mills in California that are following practices, they'll do the same thing. You might have to pay it. There might be a premium for this kind of, there might be a special run, but they're starting to adapt and do that. So it's no more on the builder than the lead certified builder has to make sure that they're following the same materials. It's the same process that they're already doing in some way or other if they're going to that kind of a building, but doesn't have to be tied to lead certification. It's just the other thing that I think you may have, I don't know if it's covered, but one of the big additional advantages from mass timber is that its installation is enormously faster because it's pre-designed, it's pre-planned, it's largely prefabricated. You have a right order problem. You have to put all the pieces in place with the right timing. But a tall building that might take months or even years to construct under traditional steel techniques might take weeks once your foundation is laid. Once you've built, and the foundation often on a building takes longer than everything else.
Sorry to interrupt you, but in Europe, even single-family houses that are made out of bricks, cement, they take years to construct. So yes, It's a way longer process.
Right. So exactly. So one of the virtues of mass timber is it is in a prefabricated form because it has to be it has, not only do you use you can use you can use the plywood equivalent as standard dimensional wood. But generally speaking, if you're building a larger building, you want to actually have an architect with you who understands how to design. We haven't gotten to the IKEA flat pack yet. We're still pre-flat pack conditions where everything is custom designed, but the design allows you a really, relatively speaking, rapid installation.
I'd like to move from forest systems to cities because when I was preparing for our conversation today, I noticed that many of the same ideas appear in your work with Leaf Island. For our audience, Leaf Island is based on the idea that cities can be designed to perform more like natural ecosystems. What does that mean in practice? And if you could tell us which urban problems can be addressed by adding more vegetation, soil, water.
Well, first off, I thank you. I think we're going to be living in cities. Many of us are living in cities. By the end of this century, the UN predicts 80% of the planet will be living in urban or semi-urban environments, which means it's pretty important to think about cities and how they fit in the natural landscape. And I think we've treated cities as places sort of that are apart from natural systems. We built them out of steel and concrete and some earlier wood, but now brick and glass and things that don't really feel that compatible to plants and living things. But that doesn't mean they aren't. And I think we need to start using not just the metaphor, but the practice of a living respiratory process with cities. And the first piece where that looks at, or the first two pieces, is that we spend a lot of energy getting rid of extracting resources and then using them and then throwing them away. And generally speaking, with a city, that means finding someplace elsewhere and making our waste somebody else's problem. And the first thing to notice when you start thinking about these things more systematically is that nature doesn't recognize waste. Waste is an entirely human idea. It's a human thing to say, I want to take that from over there, use it for a little bit and throw it over there and not think about it. But in a natural system and in nature, every output is an input. When our bodies die, we become food for something else. If there's a flood that happens, something else benefits from that flood. All these different processes are continuous. Something ends, something else begins. And if we think of cities more like that, and we think of reusing our own waste material, we start by creating a more plausible future. Because if we're going to be 80% of the planet is going to be in cities, and all cities do is take things and throw them away, we're going to run out of things to take, and we're going to run out of places to throw them away. And already, let me just, as one modest example, do you know the highest point on the eastern seaboard of the United States from the tip of Florida to the country of Canada?
Somewhere in Appalachian Mountains.
No, that's actually inland. I didn't mean the high, I meant on the coast, actually sitting on the land,
Then I have no idea.
Okay. It is the New York City's former garbage dump. It's called Fresh Kills. The highest point, they finally stopped adding to it about 25 years ago. And it's about, after 30 years, it's about to open it's actually a pretty beautiful set of parklands, please. But it took them 30 years to figure out how to do it. But that's how much just New York City managed. And now when we stopped that, we started taking things into barges and throwing it into the ocean, and created a giant dead zone in the Atlantic, only about 80 miles off of New York City Harbor. And when that stopped being good, we decided to take the state of Pennsylvania, which is, nearby and has a lot of land, some pretty good farmland, and say, well, let's take some of your land and dig big holes and we'll bury our garbage there. That's no good. And that's just one city. You've got to stop doing that. But the other piece of a city is the biggest cause of unplanned death in the United States right now is heat and heat-related infrastructure. And as Europe just discovered this summer too, it's also one of the bigger causes of death in every major city in the country. I think from the numbers I saw from France a couple of weeks ago were in 1 week, they lost 10,000 people from unnecessary heat deaths. Okay. And I think that's an underestimate, severe underestimate. And that doesn't include all the other countries that also dealt with massive heat in that heat dome that covered Europe. So how do nature-based solutions respond? And what do they solve? Well, they solve the beauty of looking at a nature-based solution, because these things are interconnected. If you take one solution, you actually address a lot of different issues simultaneously. So let's start with, how does nature deal with heat? Well, the primary way that the planet cools itself is through water vapor. So through the heat of what they call the evaporative cooling effect, the same basic technology that we pirated from observing water and steam and put into air conditioners. It's the same physical process. And the planet has been using that for a couple billion years. So it's well understood. It's a well understood process. And it comes in two flavors. It comes in one flavor, the water that evaporates off of the ocean and large bodies of water. And that's the the cooling that comes, and this is where we're going to take it further, through the evapotranspiration through plants, through the system, the process we know as photosynthesis, where plants take carbon dioxide. So they're doing two things. They're already doing two things just through the nature of what they do. They're taking carbon dioxide out of the atmosphere. They're converting it into oxygen, which is how you and I can be breathing now. Because if plants hadn't figured out how to do that, we wouldn't have an oxygen-based atmosphere, and we wouldn't be able to have this conversation, or at least we'd be in some science fiction movie in some other kind of silicon-based life form, having whatever passed for communication. And secondly, they do that by emitting oxygen and water vapor. So that's the cooling power of plants. And that's what keeps the amount of the real thing that cools this planet, in spite of all the carbon dioxide that we have, is actually the water vapor that acts as an albedo effect. It acts as actually reflecting sunlight off the planet. It counteracts a lot of the greenhouse effects. And it's a really powerful tool that that isn't patented. And it's been around photosynthesis has been around for 200 to 300 million years. It's been field tested in every imaginable set. It's a very durable, very effective technology. It comes in all kinds of formats and sizes and shapes and capabilities that can be adapted to all kinds of different places. And we've tended to ignore it because it isn't patentable. It isn't an industrial process as we understand it, and we want to ignore it. That doesn't mean it isn't working better and more efficiently and more effectively as a carbon removal device and as a cooling device than almost anything we have around. And it certainly has solved the problem of scaling. So the question is, how do we take this power of plants and how do we use it? So, as you know, Leaf Island we named it Leaf Island after what we call the Leaf Island effect, which is the power of the cooling of plants is so effective that if you take the roofs, if you put enough complex leafy green material, which is essentially meadowland equivalent, doesn't have to be trees or forests to do this. On the roofs, the side walls, that is to say, tall buildings have 4 walls, which would be a great deal more additional real estate, and the flat surfaces of the city to create roughly the same geographic surface area that the land had prior to you putting the buildings there, which turns out to be about 35 to 40% plant cover. It's not the whole island. you can actually reproduce the ambient temperatures of what that landscape would look like without the buildings being there, without having to remove the buildings. So that's the power of cooling. You can actually affect the local ecology directly. And if you do this at scale, you can really create massively improved local climate effects. And a city like New York is about 14% parkland, and we need to be at 40%. So that's the difference that we would have to cover. Other cities are much greener. For example, Singapore has already gone further than pretty much any place else in the planet on intentionally greening its urban structure. That said, China is not far behind. China is actually literally in their remarkable construction patterns of that country is building a whole city that's largely plant-oriented, green, what they call green cities. Every 3 to 5 years, they're putting more out there. So they're putting millions of people into green cities every year. They're also burning more coal than anyone. They're putting in more nuclear plants. They're also building more solar capability than anybody else. So they're basically the best and the worst of them. So that's the principle. So if you start to put plants, what are some of the co-benefits? Well, the first one is you can locally reduce temperature, not only for the building, which saves the building a certain amount of energy for cooling in the summer and a certain amount of insulation for heating in the wintertime. That's particularly true with a styrofoam-based product because it adds substantial amount of insulating capacity because, of course, one of the most powerful insulators is controlled air. And what is styrofoam but basically air contained either inside or outside, the bubbles. So it's a good insulator. But also you provide a capacity to absorb the next big urban problem. So if heat's number one, number two is stormwater and water removal and water capture. So what does putting more plants in? Well, putting more plants need water. So you're basically building reservoirs and capture systems. So in New York, like many cities, they have what they call a combined sewer system. So that combined sewer system means it combines your stormwater drainage with your sewage system. And the reason people did that was it was efficient. But in the United States, at least, what they didn't think about was what efficiency meant. So every time it rains more than, and it's about, I think roughly 2.5 or 3 centimeters an hour in New York consistently, you start to fill up your storm system and it starts to overflow and you get basically sewage water in the rivers around the harbor. And that's a really serious problem. So containing, capturing stormwater, keeping stormwater. Right now, most cities not only don't capture the stormwater of buildings, they don't capture the stormwater of roads. They have hard surfaces pretty much everywhere that's not open parkland. Or yard land is covered over. It's a parking lot. It's a roadway. It's a concrete sidewalk. It's a rooftop. It's all of these different things. And that becomes a really powerful problem because by not controlling the water, by not allowing it to sink in and infiltrate into the landscape, it has to go somewhere. And it goes into the nearby waterways. It starts flooding. It does creates all kinds of damaging effects downstream and elsewhere because we aren't managing it and putting the water where it wants to go, which is in the soil so it can percolate slowly wherever it needs to go. So you have a stormwater effect. One of the next issues that happens is plants are powerful air filters. The cilia on most of the plants that we use is a powerful adherent to the sub 2.5 micron particles, which are too small for your lungs to filter them. So that's the main trigger for asthma, for COPD, for respiratory-borne diseases of all kinds, and which, of course, are much more severe in low economic areas than they are in wealthy areas. And part of the reason is wealthy areas have more plants. Just take a look at most cities from a high building, and the places that have fewer plants map very closely the places that have less money. The places that have more plants and more trees, it's a pretty good signifier for where the money in that community is.
Thank you very much for this answer. I would say that it's particularly relevant because most existing cities cannot simply be demolished and rebuilt. Of course, it's not the case for countries at war, but for most countries, the real challenge is improving the buildings and infrastructure that are already there. But companies and cities also need evidence that these projects actually work. Green roofs, planted walls, wetlands, and other forms of green infrastructure are linked to benefits that you've just discussed. That's cooling, stormwater management, energy savings, and biodiversity. So my question here is, how should those benefits be measured, and how long does it normally take before you can properly judge whether a project is delivering results or not?
Well, the challenge is we don't have a single consistent way to measure it. Traditionally, a green roof, just stay with a green roof, is paid for by a particular building owner. So from their point of view, it's an economic question. Okay, how much money are they saving? How long is it going to take to recoup their investment? How long is it going to happen? Is it going to interfere with their existing warranties on their roofs, et cetera, et cetera, et cetera? Because unless it was a new building, in which case you built it in, it's not an integrated answer. And the answer to that is it depends, but generally speaking, where roofs are now, it's a 10 to 12 year payback period. Now, for some people, particularly those for whom it's an important thing to do, that's enough. For other people, it has to be a 3 to 5 year payback period before they'll consider it. Now, that's one set of benefits. The temperature benefit not only benefits the building owner, but it benefits the people on the street and the neighbors nearby. But the building owner doesn't care. The city cares. But do they care enough? The health benefits, the building owner doesn't care, but the community cares. But does the city care well enough? The stormwater, now there the city cares because it has to deal with the effects of water. But so where does that play? So those are all the co-benefits, what we call the co-benefits are not measured under the same scale and size. And we've isolated the benefits for most people making the decisions about green roof building limiting them to one or two more easily quantifiable. Your next question of how do you tell, generally speaking, a green roof needs to grow. So you'll start to see the effects, and depending on when you install it, anywhere from 3 to 9 months after you've installed it, depending on the growing season and your plant mix. And then you'll see again, then at that point, it's just a maintenance like any garden. And if you use, native plants and species that are habituated to the climate and the environment, you'll have relatively minimal maintenance. You still need to, in most cases, you'll need to to water it, and you'll need to, but you've got to generally roofs, again, the goal for most people is to make sure that your your green roof is designed to last at least as long as the roof underneath it. So, and then everything else is great.
Got it. I wanted to ask this question because I think it's very important for sustainability reporting and investment decisions, because it's not enough to just say that the project is green. There needs to be a clear way to measure its performance. The other issue is what happens after installation, because what do organizations most often underestimate, in your view, when they invest in green infrastructure or large restoration projects? Is it, let's say, cost, maintenance, permitting, long-term responsibility, coordination between different parties, or something else?
Well, I think that's something that's emerging because for different cases, it's all of those in different situations. Yeah, that's a. I would say the first problem in the United States is permanent. First off, there's no, there's 50 different states, each one with a different set of regulations, but permitting is often happens at the local level. So there's 20,000 different groups around, all of which maintain certain kinds of permitting rules. The United States is extremely suspicious of things that happen in other countries, regardless of how well they are. I look at why there are, of the top 40 or so economic countries, of the various countries that played at the World Cup, every single country that played had a universal health system except for one. Which one was that?
States. The United States.
Okay. So they've been building with mass timber. They've been using green, since the early 1970s in different parts of Europe. It took until 4 years ago for basically the rule structure to be developed so that the individual states in the United States could accept permanent underwriting instructions for accepting mass timber under a regulatory body of what a permit should look like. And again, that was statewide, and the states only give you a general okay. It's the local city that makes the actual decision. So permitting is insanely overcomplicated, and California and New York are both more complicated than the average complicated. It's already complicated anywhere, and it's extra complicated in California and New York. That said, what do we have? We know that here's an example I often use in conversation. 7 or 8 years ago, Germany decided there wasn't enough. Its solar penetration on a home-based solar was going much too slowly, and they wanted to increase it. So what's the single act that they did? They changed their permitting structure. They went from a 6 to 8 month multiple permits from multiple places process, similar to what we have in the United States, to a 1 day, one place. And if you came with the contract and your installer and your financing ready to go, they guaranteed you a 24-hour turnaround. And solar roof penetration in Germany skyrocketed from 2 or 3 or 4% to almost to above 30%, and it's growing further. And that was, because it's a controlled study, that was almost exclusively because they changed their permitting structure to make it a much more user-friendly permitting structure. That's, of course, there. The other piece is because there are so many social benefits for green infrastructure, there's a lot of communities, cities, New York is among them, that actually think this is a good thing. So they're willing to subsidize some degree of, or even a large degree. There's a solar roof subsidy, green roof subsidy. There's also a solar subsidy in New York City that will literally pay the same cost as the roof is to a roof like ours is to install. So you would think that's great. They're willing to pay literally 100% of the cost, which makes it essentially, well, not entirely free, but close to free for the landlord. But it takes 18 months to get through. It's a reimbursement process. It's to the point where the program has been in place since 2012. And they, last year in the 2025 annual report, where they talk about how well they're doing in climate, they bragged about their having completed their 31st installation under this subsidy program. Now, my company has built 2 of those 31, so we're not like out of this conversation. But that's part of the problem. So the permitting structure that's complex is a completely opposition to the understandable city desire to improve its stormwater management, reduce its heat burden and the urban heat island effect, to produce the sanitary, and to give people, basically more green roof cover for all kinds of reasons. But the way the city understands how it can work is completely oppositional to what it wants to do. So as a result, they have one of the most generous subsidy in the United States, and almost nobody takes advantage of it. There are 1.1 million physical structures in New York City. They've done 32 now that they were in the middle of completing 32. So maybe 33 started since we started this conversation.
So as always, excessive bureaucracy is the blocker.
It's one of the blockers, and it's not one we should ignore, but it's one of them. The other big blocker, I think, is that we're relying on the private sector for a social good. And that's a structural imbalance that we have to get over. Either greening our cities has major community benefits, and we need to work as a community to improve that, or it's just something that people do on their own private interest. And until we understand that more effectively, we're going to constantly be fighting against ourselves, because the penciling out, as they call it, of green roof infrastructure has to grow before it can become cheap and a commodity. But it's not going to grow until it has basically a public-private intervention where it says this is good for the community. So we're going to subsidize, and that's not anything unique to green roofs. That's how every major technology, the one that we're talking about. How do you think computers came into being? How did the internet come into being? How did the railroads cross the landscape? How did cars happen? All of these things all of these major improvements in social innovation. And I suspect there are counterexamples, but I would be hard pressed to find one. They're all due to massive public subsidy up to and including today. So why would we somehow change the rules for green infrastructure?
That's a very good question. Also, that's a very useful reminder that nature-based solutions still need proper management, funding, maintenance, and accountability.
Exactly.
Thank you. And before we finish, I'd like to bring this back to what businesses and decision makers can realistically do. Let's say for a company, developer, public agency, or sustainability team that wants to support climate adaptation without making claims it cannot prove. What would be the best and what would be the most practical place to start?
I think the most practical place to start is by improving the plant cover and the stormwater capture of every city, and then rethinking, because those are very much within the wheelhouse of any community. Trees, planting trees, increasing the stormwater capture through creating basically what they call bioswales as well. That's already public community work. That doesn't require anything above more than intelligent planning. And the good news is cities are doing that all over the world. Secondly, increasing the amount of plantscape, which is to say recapturing unused urban areas for microparks, creating areas for urban gardening and farming, whether it's on an individual scale or whether it's more formally, or even using rooftops for farming. I mean, or building, all of those are well within basic processes that don't require anything particularly special.
Community gardens. This is already a thing in Europe,
right.
Even in New York.
Right. Well, they're not as many, and the space for community gardens fights with the space for affordable housing. So, but they need more of both. They sometimes argue about the same individual property. But in Europe, for example, here's something that people did decades ago. Most railroads had made arrangements. As you go, there are small community strip gardens, not individual strip gardens on the edges of most national railroads across Europe. How did that happen? Well, that originally happened because as part of the early unionization and workflow management, the railroads agreed as a benefit to the workers that they would allow them to use unused land for gardens so they could so they could grow their own food. That's a brilliant, adorable, easy idea. We should be doing versions of that everywhere. And those are just small ones. If you're building a new building, if you're talking about a new construction or a new community, you have a lot of flexibility of how you do that. There are everything from advisory groups that will help you think about it to planning groups that you already have. There's lots, big companies. I was recently at a meeting at a company like JLL, which is a global real estate broker.
I used to work for them.
Okay, so you know that. Okay. But the point is, even companies of that scale and size have gone fairly seriously into what does environmental sustainability planning look like? What does it look like at the contractual level? What does it look like at the leasing level? What does it look like at the new construction level? What they aren't really doing is what does it look like at the retrofit level? But that's other people's work. So these things are happening. They happen in different ways. Different cities have offices now that are supporting that. New York certainly has one. San Francisco has, Los Angeles has one. I imagine Chicago has one. I imagine every city of any size. I know Paris has quite a bit of both mandate and support for different things. Every new parking structure over 30 square meters in Paris has to have a certain substantial percentage. It's either plants or solar or both. Solar and plants, by the way, work together very nicely. So that it's not an either or. That's another additive. That's another area where there's additive value, where your efficiency, we often aren't thinking about the fact that the system efficiency is often much higher than individual efficiency. And if we look to maximize individual efficiency at the expense of system efficiency, we don't often get the best outcomes. I think the last thing I want to say is we underestimate how much people like living in the landscape and living outdoors, and how much benefit, very unquantifiable but significantly important benefit it has. And I think we need to be thinking about ways that bring people back into relationship with the world in which we live. And this is one of the ways that can happen, that's available to us, and that allows us to think about a city that's going to thrive over the next 25, 30, 50, 75, 100 years, as opposed to a city that's going to become essentially unlivable because it'd be too hot.
Also, there is another thing, I've heard it, I think last week, even being close to the nature, going outdoors, this is like the most effective antidepressant. Not medication, but just being close to the nature, another health benefit.
It goes even further. It is actually medication in Japan. They call it forest bathing. It's medication in Germany, and it's becoming medication in increasing numbers of countries around the world. So it's not only has it been demonstrated to improve your emotional well-being in all kinds of ways that you can just test. And test it yourself. Go outside, spend a day in concrete, go outside into a park.
We encourage everyone.
Yeah, you don't need me to tell you that. Do it yourself. Demonstrate to your own self whether it works or not. Or your kids. Where do they like to be? Hopefully away from a computer screen.
Exactly. And, all right. And I think on that positive note, we'll end our today's conversation. So Josh, thank you very much for joining me today and sharing your perspective.
Thank you, Carol. And I look forward to, it's been an enjoyable afternoon, and I look forward to seeing the fruits of this experience.
Thank you. This conversation has shown why issues such as wildfire, forest restoration, construction, water, urban heat, and local economic development cannot always be treated separately. For businesses and sustainability teams, the practical lesson is to look beyond a single product or environmental claim and consider how the wider system will be funded, implemented, measured, and maintained over time. To learn more about Josh's work, you can visit the Center for the Study of the Force Majeure and Leaf Island. You can also find more interviews, articles, and practical sustainability resources at netzerocompare.com. And if you would like to receive our latest updates, you can subscribe for free to the Net Zero Compare newsletter through our website.